so common, we use it as a casual metric for infinity. Our planet is completely covered in the stuff. Deserts make up nearly 1/3 of the Earth's land surface, holding billions of tons of loose, dry sand. Right in the middle of all that sand sits Dubai. In just a few decades, it expanded from a quiet coastal settlement into a towering megacity of concrete and glass. But to build those massive towers, Dubai faced a serious logistical barrier. The millions of square miles of desert immediately surrounding the city are entirely useless for construction. To mix the concrete for its own skyline, Dubai actually has to import sand. They ship millions of tons of it across the ocean from Australia. Hauling raw earth across the Indian Ocean is incredibly expensive. It requires massive cargo ships burning thousands of gallons of heavy fuel oil just to deliver a basic mixing ingredient. We can't build a city out of just any sand. Concrete requires a highly specific geological variant, and the supply of that exact material is rapidly running out. To understand why you can't build with desert sand, you have to drop down to the microscopic level. In a desert, sand is shaped by wind. For thousands of years, heavy gusts pick up these tiny particles and smash them into one another violently. Every time they collide, the rough edges chip off. The entire desert acts like a giant natural rock tumbler, constantly grinding away surface imperfections. The result is a microscopic marble. Desert sand grains are perfect polished spheres. Mixed into concrete, they act like a ball pit. Put heavy pressure on them, and they slide right past each other, offering no grip. The sand found in riverbeds, lakes, and ocean shores is formed entirely differently. Water acts as a thick fluid cushion, protecting the grains as they bounce along a riverbed. This prevents violent collisions, so the sand retains sharp, jagged edges. Mixed into cement paste, these irregular shapes interlock, catching like puzzle pieces. That physical interlocking creates friction. That friction gives a concrete block the tensile strength required to support thousands of tons of steel without shattering. Our entire built environment relies on that specific microscopic friction, and you can only get those jagged edges from sand naturally shaped by moving water. Because we specifically need water-eroded sand, we have to go to where the water is. We are extracting sand straight from active rivers, coastal shelves, and lakes. We use giant industrial dredgers to strip the floor, lowering massive suction tubes to vacuum up thousands of tons of sediment an hour. This process completely clears the riverbed. It destroys the breeding grounds for local fish, removes aquatic plant life, and permanently alters the flow of the water. On land, the process leaves massive scars. Sprawling sand quarries carve deep into the terrain, removing millions of cubic yards of earth for construction. Extracting inland sand means less sediment flows to the coast to replenish beaches. The shoreline collapses inward, shrinking land masses and directly threatening coastal towns. The demand for jagged sand is so high that it has created an illicit market. In parts of Asia, illegal mining networks known as sand mafias control the trade through extortion. These illegal operations often dredge directly under active bridges. They vacuum away sediment holding the support pillars, causing the structures to collapse. Engineers are searching for alternatives. They test crushed recycled glass and byproducts like fly ash, trying to engineer replacements that offer